Hello, welcome back. I decided to go for this again. I think I kind of liked it. I'm open to feedback though. Like, do you like seeing me in the screen? Does it feel more like I'm teaching? Do you want me out of the picture? Are you watching these? I'm kidding. I hope. Anyways, so as we move forward a little bit in Unit 1 in this, I don't want you to forget any of the things you've learned about domain and domain restrictions. That's going to be important. It can also be like I'm moving around the classroom, like, no, I'm here, no, I'm here. Fun. I don't want you to forget any of those things, right? So those are still going to be very important to us as we're doing other things throughout Unit 1 where we're working with all functions, right? So we're still going to be looking at domain, but we started with that piece of it and we introduced functions because we wanted you to have like a great basis for that information. So using what I've learned about domain restrictions and functions, there you go, right? So using what we've learned, I will perform basic operations with functions and analyze the results, right? So what are some operations? Oh, this means addition. This means subtraction. Maybe there's two more we're going to look at. This means multiplication. And this means division. So when we're analyzing the results, we want to see, after we've done an operation, how does that impact characteristics of functions, right? Or how does that impact or not? How does that change or not? How does that impact domain of the new function, right? If I'm adding two functions, I'm going to result with a new function, right? It was born from these two functions that it started with. How does that change, or does it change the domain? So that is what we're going to be looking at throughout this lesson. So hopefully you got your notes ready, and let's go. Okay, so operations with functions. Given two functions, perform a given operation to determine the new function, as I was just saying, right? So are you adding, subtracting, multiplying, or dividing? Determine the domain of the new function, right? Oh, right, it was born from these two. So here we've got example 1. So I've got f of x and g of x. Remember that function notation. F of x and g of x. So when we put them together and we add them, what do we get? Here, let's show our setup. X squared minus 9 plus 2x minus 5. I'm going to get, I need to move me, x squared plus 2x minus 14, right? So I'm going to get this. So I added a quadratic, a second degree polynomial, and a linear function, a first degree polynomial, and I got a quadratic, right? So what's the, I'll do domain at the end. What about if I subtract them? X squared minus 9 minus 2x minus 5. I know you might be tempted to just write this. I encourage you to show your setup, show that process, right? That's like I'm finding it. So I've got to show something. I have to show how I found it. So x squared minus 2x minus negative 9, right? You got to make sure you distribute that. Be careful. So I'm really doing negative 9 plus 5. So that's going to be a negative 4. Right? So I get another quadratic. What if I multiply them? This looks fun. X squared minus 9 times 2x minus 5. I'm going to have to use double distribution. I'm going to have to distribute the x squared and distribute that negative 9. So that gives me 2x to the third minus 5x squared minus 18x. So now I'll distribute. So I distributed the x squared, and I'll distribute the negative 9. Some of you guys might remember an acronym called FOIL. I feel like I keep freezing in the screen, but it's unclear. And that's going to be plus 45. Ooh, I multiplied a quadratic, and a linear function, and I got a cubic function. I got a third degree polynomial. How awesome. I need a new color though. No, I'll do one more. And then finally, let's divide these. Oh no, that's not what I meant to do. Too much. Kind of ruined it though, didn't I? So f of x, x squared minus 9, divided by 2x minus 5. There's actually nothing I can do here. I can factor this, but this factors into x minus 3 times x plus 3. If you remember difference of squares. We did those on the pre-assessment the other day. I don't know how many days ago that was at this point. But nothing cancels. That really does nothing for me. I would just want to leave my answer like this. So if we take a step further and we look at the domain of each of these, are there any domain restrictions, right? So this original domain of f of x is all real numbers. Same thing here, right? The domain of this one is all real numbers. Oops, sorry. Interesting picture. Well, here, my domain is all real numbers. Here, my domain is all real numbers. Here, right? There's no restrictions. This one's got a restriction, right? I've got to look at this denominator and think, well, 2x minus 5 can't be 0. It can be negative. It can be positive. It just can't be 0. So let's solve for that, and I'm going to get x equals 5 halves. So it's going to be all real numbers, except x cannot equal to 5 halves. Or if you say 2.5, that's fine, right? So we're doing these operations, we're performing these operations, which you may have done in the past, but then we're going that step further and we're analyzing the results are, right? So you're thinking about how does this operation impact the domain and range I started with. Let's look at another one. Ooh. Okay. Here's my two friends. Domain that we start with, all real numbers. Domain that we start with, x cannot equal 0, right? We start with that right away. Let's see. Whoa. Let's get these. Where's my first two? Let's put them all up there. Let's add them. Negative 5x plus 7 plus 2 over x. Nothing I can do with that. Domain is just all real numbers, but x is not going to equal 0. Right? That's going to carry through. It's going to carry through those properties. It might develop new ones, but those old ones are going to carry through. It's going to be like the intersection of the two. So let's see. Negative 5x plus 7 minus 2 over x. Oh, all real numbers, but x does not equal 0. Let's multiply them. Negative 5x plus 7 times 2 over x. So I'm going to distribute that. So that's going to give me, well, negative 5x times 2, negative 10x over x, plus 14, isn't that? That's a 14. I hear you all yelling at me. Kidding. These x's end up canceling, and so you've got negative 10 plus 14 over x. So even though I don't have a 2 over x anymore, it's still all real numbers, but x does not equal 0. And then down here, I'm going to do f of x, negative 5x plus 7, divided by 2 over x. Well, what's easier than dividing by a fraction? Multiplying by the reciprocal. So I'm going to multiply this by x over 2. Think about it. If you divide something by 1/2, it's the same thing as multiplying it by 2. If you divide something by 2, it's the same thing as multiplying it by 1/2. I think my second example was better, right? If you divide something by 2, I'm really multiplying it by half. You're dividing it by 2, multiplying by 1/2. That's what's happening here. So dividing by 2 over x, I'm multiplying by x over 2. Okay, so when I distribute this in, I'm going to get negative 5x squared over 2 plus 7x over 2. They have a common denominator, so if I wanted to write them together, I could, but check that out. Is there a restriction? It doesn't look like there's a restriction here, right? But let's go all the way back to this one back here. You got to think about where it came from. Could x be 0? No, right? So it's going to carry those through, even though it got messed up. Think about it before you simplify, right? You've got to remember where something came from, not just what it resulted as. And that's going to be very important as we move forward. So do pay attention to where something actually came from. So if it had a restriction to begin with, don't lose that, right? Like this was a simplification, but I don't want to forget that I came from something over here, right? So 2 over x can't be equal to 0. That whole fraction. But I also have x can't be equal to 0. It's not possible for this fraction to be equal to 0, but I don't want that x to be equal to 0. So at this point, I've done 2 examples. These aren't like crazy intensive or crazy different. It's kind of just combining some things that you've done. So I would pause the video and check your understanding here. And then when you're ready, unpause and let's go over it. So now that you've given this a try, hopefully, I've got f of x and I've got g of x. And I want to determine the following. So I'm going to first add these. So I've got 2x squared minus 3x plus x squared minus 4x plus 3. And then let's simplify that. So 2x squared and x squared is 3x squared. Negative 3x minus 4x is minus 7x. And then plus 3. It probably would have been a good idea for me to think about, well, these have no domain of restrictions to begin with. So the domain is just all real numbers. What if I subtract them? 2x squared minus 3x minus x squared minus 4x plus 3. So don't forget that minus has to be distributed. So 2x squared minus x squared is x squared. Negative 3x minus negative 4x is just going to be x, right? It's like negative 3 plus 4. And then minus 3 at the end, right? Distribute that negative in. So negative 3. All real numbers. What about multiplying them? I'm going to do c down here if it's okay with you guys. 2x squared minus 3x times x squared minus 4x plus 3. Double distribution. I'm going to distribute that 2x squared first. So that's going to give me 2x to the 4th minus 8x cubed plus 6x squared. And then I'm going to distribute that negative 3x minus 3x to the 3rd plus 12x squared minus 9x. Let's see, I got some combining. So 2x to the 4th is good. Negative 8x cubed minus 3x cubed is going to be minus 11x cubed. So good with those. 6 plus 12 is going to be plus 18x squared. And then minus 9x. And again, no restrictions. Right? It wasn't born from any restrictions, and none developed. Finally, f of x divided by g of x. So I've got 2x squared minus 3x divided by x squared minus 4x plus 3. And I'm going to go ahead and I need maybe a new color. Maybe a nice red. No, a nice blue. And let's think about this for a second. So I'm going to go ahead and factor. I'm going to factor that denominator, right? So the numerator I could factor, and I could factor out an x, and I'd be left with 2x minus 3. The denominator I can factor, x squared minus 4x plus 3, and I'm going to get x minus 3 times x minus 1. So nothing cancels. I didn't really need to do that. This doesn't simplify anymore. This is as simplified as it's going to get. But I did need this denominator piece of it in order to figure out the domain, right? So I would start off and be like, well, this is all real numbers because that's the characteristics that were passed down to it. However, it develops some characteristics by dividing. So I have to look at the denominator, and it can't be equal to 0. right? So I now know it's all real numbers except x cannot be 3 and x cannot be 1, right? So those are now eliminated from my domain. So there's more practice with this available to you. I encourage you to use it as a resource and complete the practice that goes with it. But essentially what we did in this video was we used what you've done and we kind of combined a few things. We looked at some applications and ways that we are going to be using the things that we've learned about domain and the things that we've learned about functions to kind of apply it. So now we're building on that a bit and we're looking at operations with functions. There's one operation that we didn't look at in this lesson that will be coming. So if you've heard about composition, that's what's coming up next, which is another type of operation. And we will be also tying domain into that as well. So that's all coming. So if you need to go back and rewatch anything, feel free to do so. Other than that, thanks for watching and make sure that you finish all of your work. Thanks, guys.